Hi and welcome to another tutorial video. In this tutorial video I'm going to be showing you how to simplify Boolean expressions using Boolean algebra. And I've got the rules of Boolean algebra written down over here, and I've also got De Morgan's laws written down over here, which will lead for one of the examples. Okay, so let's have a look at the first example of simplifying a Boolean expression using Boolean algebra then. So this is my first example, and what I can do immediately, it strikes me that I've got two brackets with two sets of brackets with things in them, and what you can do in Boolean algebra, much like regular algebra, is you can multiply out brackets, multiply out in air quotes. So what we're doing, because we're not actually multiplying, we're anding, but what we can do is write x and x, because this is the x anded with the x, and we can do the x anded with the not y as well, but we've got to put an or sign in there as well. So do the x anded with the not y, and then we can do the y anded with the x, and notice I'm joining all of these with or operators, and we can do the y anded with the not y and joining it on with an or operator. So that's how you expand out those brackets. What I can then notice is that I've got some occurrences of a particular rule, one of my rules. So here I've got an occurrence of this rule, and if I just do it in a different colour here I've got an occurrence of this rule. So let's take a look at the one circled in red first. X and x, well that's the same as this rule here, a and a, so a and a just equals a, so that means if we're applying it in this case, x and x is just going to equal x. Write the middle part down just the same. And then if we're taking a look at the one highlighted in blue, y and not y is the same as a occurrence of this rule here, a and not a, which is equal to 0. So we know that y and not y is going to be equal to 0. This is really important when you're using and applying these rules, that it doesn't matter what letters you're using in your Boolean expression that you're simplifying. You can substitute a in these rules for anything that you're using here, which is what I've just done in these two cases. I've applied, even though we're using the letter a here, I've applied it to a case where we've got x's. And even though I'm using the letter a here, I've applied it to a case where I've got y's. Now what I can do is take a look at this whole thing here and see that it's ORed with a zero. And I can see that that's an occurrence of this rule here. And that's just saying anything ORed with 0 is that thing. So this thing here, ORed with 0 is just going to be that thing. Now what I can do is factor out again. So like we expanded these brackets, we can also take common factors out, a bit like normal algebra that you'll have learned about in maths. So we can take the x out of all of these terms here that are ORed together, and write 1 or not y or y, because we've just taken the x out of each term. And we can simplify that down, because this whole thing here is an occurrence of this rule here. And what that's saying is that anything, so in this case not y or y, ORed with 1 is just going to be 1. So we can rewrite that as x and 1. And now we've got one final occurrence of one of our rules, x and 1. So this here, the same as the occurrence of this rule here, and that's just saying that anything anded with 1 is just itself, and therefore our original Boolean expression simplifies down to just x. Okay, so let's move on to look at another example. Okay, so our second example here, I can see that as with the first example, I've got a bracket. This time I've only got one bracket. What I can do, in the same way as we did in the first example, is multiply out this bracket or expand this bracket. So I get a, b, or a, B, B, so A and B, or A and B and B. Then we can spot two occurrences of one of our rules. So this rule here is occurring twice in our expression, here and here. So if we apply this rule here to both of these cases, we get A and B, or A and B. Then we've got the whole expression is now an occurrence of this rule here, and that's saying anything ordered of itself is just that thing. So therefore A and B, or A and B, is just going to be A and B. And now we've simplified that expression. That was a slightly easier one. Let's go on to looking at another example then. So in this example here, I haven't got any brackets to start off with, but what I can do is introduce some brackets into my expression to give me the opportunity to apply some of the rules that we've got to the side. And what I notice is that in this part of the expression here, and in this part of the expression here, we've got a not b. And I can, much like you would do in regular algebra, I can take that out as a common factor. So what I write is not b, bracket, not a, or a, because those are the other terms in those two parts of the expression. And then obviously not forgetting this middle term here that we haven't done anything to, like that. Now you'll probably be able to spot a occurrence here of this rule, and that's in our bracket. So we've introduced that bracket, and that's allowed us to apply one of these rules. A or not A, and that's actually exactly the same as what we've got here. A or not A is equal to 1. So therefore we've got not B and 1, or A and not A and B. Then we've got an occurrence of one of our other rules just here. We've got an occurrence of this, and that's just saying that anything ANDed with 1 is just itself. So we can simplify this down to not B. And then what we've got is a occurrence of one of the rules that we haven't used before, and this whole expression is an occurrence of this rule. And although it's not directly comparable, because this B is an A in this in the definition of our rule here, and it's knotted, and that's the difference between this and what we've got here. We can apply the same rule. So in this case, it was A or A, not A and B equals A or B. And we can apply the same thing, and what we notice about this is that the two things that are not knotted is what it's equal to. Because the thing that's on its own here is knotted, the thing that's going to change about our final expression is that both the A and the B are going to be knotted. And that's our final expression once we've applied that rule. Okay, so that's our third example. I'm going to do 2 more examples just so you get the hang of this. Okay, so looking at our fourth example here then, I've got this Boolean expression. Well, it might look a lot more complicated because we've got 3 inputs there, but really it's not much more complicated than before, and we just have to apply the same rules and everything will be fine. So what I can do first of all then is take out a common factor, and we've got BC in this part of the expression here, and we've got BC in this part of the expression here. And if I take that out, what I'm left with is this. And then I can see I've got an occurrence of this rule right here, and that's just here. And what that means is you should pick this up by now, is that A or not A is equal to 1, so you can simplify this down to 1. So you get BC and 1, or A not A and not B and not C or A and B and dot C. We've then over here got a occurrence of this rule. So anything and one is just that thing, and if we apply that, then we get BC or not A and not B and not C, or A and B and not C. And then what we can do is in the expressions that we've got now, there aren't any pairs of two of the inputs that are that we can factor out. But what we can do is we can factor out B from this one and this one. So we get B bracket C or A and not C, or A not A and not B and not C. Just give us a bit more room here. Then what I can see here is I've got another occurrence. I've got a occurrence of just here of this rule here. And what that means is I can simplify this down to A or C. So B and A or C, or not A and not B and not C. I can then expand this out, so I'm left with A and B, or B and C, or A not A and not B and not C. And that's as far as we can get with this Boolean expression. So sometimes you may be in the... We have simplified it quite a lot from this very long expression down to here, but sometimes you can't get to a minimal form of an expression which is only a few terms long. Sometimes it can be quite a log expression which is the minimal form. Okay, so in my final example here, example 5, what I can see straight away here is that we've got a occurrence of De Morgan's laws, and that is over here. And that's because we've got what the particular law we're concerned with here is this one here. Because what we've got is two things all together. It doesn't matter that they're knotted, it's just two things all together, which are themselves completely knotted. So if you're using a slightly different notation to what I use, it might look something like this, which makes this particular part of Boolean algebra a bit clearer. So we've got two things all together, and it's a knot going over both of them, the whole thing. And if we apply this law, what we're then going to be left with is, in our case, not A and not B, because these two are going to get a knot on both of them, because that's what happens when we apply the law, but they've already got a knot on both of them. So if we just apply that, then that's what we're left with. And what we've then got is two occurrences of this law over here. So if something is knotted and then knotted again, then you just get the thing with no knots, which is completely unknotted. So it's got no knots next to it. So these two simplify to A and B if we apply this law. Then what you'll probably notice is we can take out the common factor of B, and that's what we're left with. Then we've got an occurrence or over here of this law, this rule, and we can see by that rule that this part of our expression will simplify to 1. So we're left with B and 1. Then finally what we've got is a occurrence of this law here. So something and 1 is just itself, and then what we're left with is B, if we apply that law. Okay, so that's just 5 examples of how we can use Boolean algebra and these rules and De Morgan's laws to simplify Boolean expressions. What is worth noting is that these laws down here are derived from these rules up here. So if you don't have, if you can't remember these ones, then you don't need to remember them basically, because say for example we're looking at the top one there, so A or A and B equals A. We can prove that to ourselves using these laws. So starting from the left hand side, we can take out an A, so we're left with 1 or B. Apply the rule anything or 1 is 1, and then this simplifies to 1, so we're left with A and 1, so we're left with A and 1, and then we can apply this law here, A and 1 equals A, so anything and 1 is A, or sorry, anything and 1 is just itself, and then we're left with A. So we can apply, we can factor out and apply 2 of these rules to get the same result as just this law here. So that's so these are all examples of derived laws. Okay, so that brings us to the end of this tutorial video. Hope you found it useful, and thanks for watching.